All right, this is routers class. We're on week 5 already. This was Wednesday. Items the students need to do: they need to be working on the chapter 4 lab, and the only difference is when they get done figuring out the network, they have to put it in Packet Tracer instead of just drawing it and configuring it here in the classroom. We spent a little bit of time. We talked about static dynamic routes, we talked about link state, and we talked about distance vector. Distance vector is what we're focusing on. We got RIP and EIGRP. Sharing information from one router to another. Okay? We covered some specific terms, and then we looked at lots of examples to understand this. So we got about halfway through the chapter. You have to understand what a routing table is and how routing tables are built. That's what we're talking about, one way to get information in the routing table. Convergence, that routing table knows what all the other networks have settled in terms of routes. Now, it doesn't have a picture of everything. That's one disadvantage of distance vector. It only knows what its neighbor tells it. It only knows what its neighbor tells it. All right, and we talk about periodic updates. They come on a certain timing. I just showed you down there, RIP every 30 seconds sends an update, and lots of things use that, periodic updates, where they send some information and make sure they know if a device is still there or not. Triggered updates: when something changes, it'll send an update. How to know something was changed? It could be sending hellos. Other methods to look and see if a route has gone away or a new route was added. Bonded updates: that's where it's only going to send information that deals with the specific update rather than sending the entire routing table. An example would be RIP every 30 seconds, so it's periodic. It sends the entire routing table, so if there's changes, the router can compare to what it has gotten before from RIP and make the adjustments. EIGRP can use triggered updates and send bounded updates. So it's much more efficient in the use, but it's a more complex routing protocol. Remember, complexity is not necessarily good, depending on the situation. We took a look at how the system works here at NIACC in terms of sending information in and out, and then we looked at a lab scenario, and this was what we showed initially, and then the students, based on this, were to figure out as well as they could how much of the network. And you'll notice we have a 10 network, and we have one of those 10s, 10.220, we got through EIGRP. The D shows EIGRP, and then we have 2 connected routes, so we could connect them right to the router. And then we have another network we learned through EIGRP, which is further away than the 10.222 because we can tell by the numbers. I told the students, this is what we ended up with. I told the students that the WANs were the same distance, and so they knew that router 1, the one with the diagram we just showed, the 192.168.10 was directly connected, and then the 10.110. Up there in the top, that route was been the 10.222, and we added the 10.330, but we didn't actually configure it entirely on the routers. And that's it for today. They need to do the lab for Monday and finish going through the curriculum on chapter 4 for Monday.